All right, so this is gonna be our third lesson, and we're gonna be talking about programming languages. So this is also gonna be the first lesson and the start of our programming languages section. So make sure to kind of pay attention as Daniel and Zenkai are gonna lead this lesson and basically explain the differences between various programming languages.
All right, so today we'll be kind of recapping what we did last week with our short intro programming during the overview of cybersecurity and overview of computer science, and then we'll introduce some stuff, introduce some languages, talk about some of the differences in all these languages, and kind of each one's significance, and then we'll do a live setup of a coding environment, and then we'll do some more talk about reason code, and then we'll cap it off with a conclusion. And if you guys have any questions, then yeah. All right, so going into last lesson, we talked our previous lesson, we talked about what a programming language is. So basically a programming language is you giving your computer or any computer instructions and expecting it to have some kind of output, trying to get some output, and you use it to compute stuff. So it first started off as like really simple like math, but then as computers got more advanced, you could add logic and create complex programs. And so there's a lot of different types of programming languages we talked about. We'll quickly review that later on as well. But so some examples of programming languages that you guys might have heard of are like Java and Python, which the two we're going to be using in this club, but then also things for like websites like HTML, JavaScript, CSS, as well as more general purpose languages and simpler languages like C++ or C, things like that. But yeah, so for all these programming languages, they all have a main goal, or they all mostly have a main goal. And so there's the six here: reliability, robustness, usability, efficiency, maintainability, and security. I will quickly go over each one. So reliability is like, making sure when you run a program, it'll reliably give you an output. The output won't change, won't be random, unless you make it random, of course, or pseudo random. And then you have robustness, making sure that your language can support a lot of code. It can run on computers well. And then you have usability, where it's easy for a programmer to write the code out, or like take an idea and put it into code. Efficiency, where it has a good performance. The program can run quickly, and it won't take up too much computer memory or RAM or whatever. And you have maintainability, which is like when you write updates to code, or when you're publishing new versions, it's easy to publish. And there's all like everything about compatibility, making sure that previous versions are compatible with current versions, and current versions are compatible with future versions. So that's like backwards and forwards compatibility. And then you have security, which is just making sure the programming language can be easily exploited, or broken into, or like it doesn't have any vulnerability or any flaws. So yeah, those are like kind of the six goals of programming. And now we'll go into the two programming languages that we'll be focusing on in this club: Java and Python. So for Java, or for both of them actually, they're both general purpose, so they can be used from anything, for like huge projects that the government may make, to a website that you're just developing on your own. And they're both high-level programming languages. We'll go into that more later. They're both cross-platform, which means they can run on Windows, Linux, Mac, and they both have a bunch of standard libraries. And sometimes you hear it as like batteries included, and it's like the language comes in with a bunch of functionalities and capabilities that you can already use. And if you guys have ever used Java or Python, you might know about it. For example, on the Python, you have or in Java, you have all these math functions. In Python, you do as well. And both of them are really prominent. They're used by a lot of people, and they have strong communities where where the languages are constantly being updated, or new ideas are coming out. And whenever you have bugs or issues, or and you need a fix or something, you can go and Google and figure it out, and there'll be people to help you. And so now for more into each individual language, Java was first appeared in 1995 and it was written by James Gosling at Sun Microsystems. Sun Microsystems later turned into Oracle. And I don't know if you guys know, yeah, Oracle is a pretty big company nowadays, and it's still maintained by them. And so Java, when it was being created, it had 5 main principles, and Gosling was he was actually working with 2 other guys, but Gosling's mainly known for it. And he decided that Java needed to fulfill the goals of making it simple program that's object oriented, which is a type of programming paradigm we'll get into later. We'll talk about that. And familiar, so a lot of people can recognize it, a lot of people can use it. It must be, second, it must be robust and secure. So it is able to handle a lot of code and able to function at like large. It's able to scale. So it's able to scale, and it's secure, so it's not easily like hacked into or broken into or exploited. Java also must be architecture neutral and portable, so cross-platform. Basically, you can take a piece of code that you wrote in Java and go onto another guy's computer and run it. It must execute with high performance. So when you want to run the program, when the program's running, it'll run quickly and efficiently. And it must be interpreted, threaded, and dynamic. And so those are maybe some terms you haven't heard before. But basically, I think, yeah, just for now, I guess we'll just keep it that. Interpreted, we'll talk about that. Threaded, that's talking about when you're running a Java program, how you can have multiple threads and it can run not just in one kind of process, or it can split up into multiple. And dynamic, so it's able to adapt, things like that. And then you have like garbage collection, or yeah, we'll just leave it at that. And then we have Python. Python actually appeared earlier than Java, even though it's considered an easier language for people to learn. It appeared in 1990 by Guido van Rossum at CWI. I forgot what CWI actually stands for. But basically, it's an institute in like Denmark or Sweden. It's for tech. And then they had their kind of principles as well. So they wanted Python to become, or here's a list. So beautiful is better than ugly. So they want Python was really about keeping the program simple and easy to understand, easy to write. It's really focusing on humans, I guess, human readability. So beautiful is better than ugly. Explicit is better than implicit. So knowing what the program is doing, that's pretty important. Simple is better than complex. So keeping your program simple, not having to have a bunch of redundant code or code that's that a person, or we'll talk about it later, but like abstraction, like keeping it simple is better than complex. And then complex is better than complicated. So that's talking about how even when you do need to write these complex programs, you don't want it to you want, if it's complex, it'll be understandable to a human still, but it might take some time. But complicated comes to a point where the human can't even understand it, even if it was written, or like it understandability can come after time, I guess. And then readability counts. So making sure, so Python was talking basically all about human readability, making sure that people can write it, read it, things like that. And so those are the 2 languages that we'll be focusing on the club. And with these 2 languages in mind, so Java and Python, both multi-platform, we'll go into differences between programming languages and kind of tie in how Java and Python relates to each one. By the way, if anyone has any questions, this might be kind of complicated, you can feel free to put them in the chat and we'll try to answer them after. All right, so now talking about just programming languages in general, not just Python and Java, we have high level and low level languages. Both Java and Python are high level. And the difference between high level and low level languages primarily, we talked about this last meeting as well, but low level languages are easy to understand for the computer, hard to understand for the person, and high level languages easy to understand for the person and hard to understand for the computer. So high level language you can think of as being built off these low level languages, and a lot of the dirty work is abstracted away or basically hidden from the user perspective. And the high level languages has code and syntax that is able to do complicated tasks that low level languages you would have to write out lots of lines of code into, and you can, a high level language takes all that long code and makes it into a simple function or line of code or like couple characters. So for high level language, these are usually interpreted. So by interpreted, we'll actually talk about this more later, but interpreted is basically the code is taken and it's read line by line after being converted to low level language. So you take the code and it's actually usually compiled. Oh, actually we'll talk about this later. But though they're interpreted, they have dynamic constructs, open classes, message style methods. So basically all easy for the person to understand. As a performance though, because it has to go through all this like you have to take it, and because you're simplifying it, you have to unsimplify it basically for the computer to understand. So that's going to take some time to process. And then you have flexible syntax, easy to read. So it's easier for the person, harder for the computer. And you got a large community usually because these programs are used by lots of people and they usually have a lot of support behind them. And so, but low level languages on the other side are closer to the computer. They're a lot faster because they're a lot easier for the computer to understand. And they have really good performance, but it's a lot harder to learn. And here at the bottom, you can kind of see the languages that are high level and low level. And so you have machine code and assembly, which are both low level languages. And over here are like the higher level ones. And C and C++ are closer to low level than high level. And then Java's kind of in the middle, more towards the high level language, I'd say. And then you have some other languages as well. And so high level is closer to person, low level is closer to computer. All right, so now talking about interpreted versus compiled, so it says these are interpreted. We're kind of talking about how a computer program actually runs. So when you have a compiled or interpreted languages, and honestly nowadays with modern languages, a lot of languages are both. They have a combination of both, or they allow a combination of both. And so interpreted and compiled are basically, it's the difference between when you run a program, right? When you type your code and then you hit run, so you might have a button that says run, right? Or you just click on something and it runs a program. In interpreted language, what would happen when you hit run is it takes your code and then it runs it, or on whatever platform it's using. It might be using a virtual machine, as we'll see in Java and Python, but it'll take that code and then it'll run it, and it'll read each line of code line by line, and I'll look at the first line and I'll say, okay, well, this is what it wants me to do. So then it runs that line and it goes to the next line and runs that line, and it just does that the whole way down. And that's interpreted program or interpreted language. But then for compiled language, you can think of it as taking the whole program, not reading it line by line, but taking it just like the whole program and then compiling it, so making it into something the computer can understand, and then running it. So interpreted is like compiling, or interpreted it's like taking it line by line and giving it to the machine to run, and compiled it's taking it the whole thing, making it into machine code, and then running it. And so there's a couple advantages of each one. Interpreted is easier to implement because you don't have to deal with a bunch of code. You just look at one line, and all you have to do is analyze that one line, and then you just continue. And then after analyzing that one line, so developing these languages are usually easier to make. But when you run these programs, what happens is it executes on the, okay, so actually the last second bullet point might be kind of confusing, but what happens is you take the program and then it reads the line and then it runs it. So it's kind of executing on the fly, right? The next line you run it, and then, but the problem with this is when you run line by line, you can't really increase performance or anything because you're only running one line at a time. And so going to compilation advantages, compiled language, when you run the whole thing, or when you take the whole thing and you compile it, you can kind of optimize the code. You can try to make its performance better. And so it takes time to actually compile the language, but after running it, when you're actually running it, it's a lot faster execution. And so actually talking about these two languages, we should probably go back to the last slide. Let's go back to the last slide. So machine code and assembly are actually the low level languages that a lot of these languages compile to, or actually all these languages compile to. So what happens is you take something like Java, you take something like C, you take something like C++, where you have some code. We can share some later actually. And they have their own programs, they have their own software that takes your code, and then it takes it and then it converts it to bytecode. Right? So like B-Y-T-E, not like B-I-T-E. But bytecode, like a bit, a byte, like, like a computer byte. Okay. And then it takes that code and then it converts it to machine code or assembly, and then the computer is able to run it. And so interpreting, what happens is it takes one line, converts it to bytecode, and then the computer runs it. But then compile, you take the whole thing and convert it all to bytecode, and that's where the optimization can happen. Okay. So yeah, well, that's interpreted versus compiled. We'll quickly go over how Java and Python both use compilation and interpret the code that you give it. So what happens is you run Java source code with and usually your file ends in .java. It goes into a Java compiler where it compiles it to bytecode, but then the bytecode goes to your run. So this is your compile time environment where you're compiling it. Runtime environment is when the code's actually running. It compiles it and basically uses the Java virtual machine here. And that's the virtual machine that actually runs. So every time you download Java onto a computer and set it up, you have a Java virtual machine on there. And then you run your bytecode is actually run on the Java virtual machine. And that's passed to your operating system and hardware. And what makes it cross-platform is every computer, whether it be Mac, Windows, Linux, all have Java virtual machine, and that basically helps it. So it gives code. It takes your code and makes it into something that individual operating system can understand. And so that's how the basically process first gets compiled to bytecode, and then the interpretation happens when the operating system, the hardware, is running it and is reading it line by line. And so for Python, it's similar. You take your source code, you compile it into bytecode, and they use, instead of the Java virtual machine, the Python virtual machine. And then we'll talk about this later, but the libraries, the batteries included stuff is added on into the virtual machine, and then it gets given to the computer, the operating system, the hardware, and the operating system runs it with no issue. And so both of them are actually compiled and then interpreted. There's also another point that I wanted to add, but we might be a bit behind time. So there's something called just-in-time compilation. You guys can probably search it up. There's probably gonna be a video on it, but both Python and Java actually use just-in-time compilation, and basically it takes interpretation and compilation's benefits and kind of combines them together. And okay, let's see. Yeah, I think that's about it. Let's see, we'll go to the next one. Okay, so programming paradigms. So that was basically a quick overview of compilation versus interpretation, how Java and Python each process it. If you guys have any questions, make sure to put in the chat, but I'll go ahead and move on to programming paradigms because we're a bit behind time. All right, so we have imperative programming. Oh, actually, I should talk about what paradigm is first. Okay, so paradigm is kind of a method, a way of how to do something. And you can think of a everyday example of a paradigm is like when you get up. So when you get up, there's a way there's like an overall method or way that you get up, right? So how your morning routine goes. So sometimes you might get up and then you go over to brush your teeth, and then after you go brush your teeth, you wash your face, you go eat breakfast, you go to school, you roll over to your computer that's next to your bed, and that's your school. But a paradigm is basically a way that a computer programming language accomplishes something you tell it to do, or like how it processes your input. And so there's two types of main paradigms. There's imperative programming and declarative programming. And imperative programming is like you give it you have to okay, so for imperative programming, you have to tell it explicitly how to do something. So you can think of it as and usually you see imperative programming a lot. So if you guys maybe imagine you had a robot, I guess, and then you wanted the robot to move in a square. So for imperative programming, you would have to do something like you would have to tell it to go forward. So maybe make its motors roll forward. And then after rolling forward a certain distance, you have to tell them that distance. You have to turn. And then after turning, you have to do another turn. And then, or you'd have to move some more and then turn again. And that would be how you make a square. And you'd have to tell the computer how to do it, but then and give it like kind of explicit instructions. But on the other side, declarative programming is more like you're just telling the computer, do this. I don't care how you do it. As long as you give me a value, as long as you give me an output, I'm good. And so a lot of there's kind of subsections of imperative programming. So structured, the structured programming paradigm is basically your program has a structure. It kind of just, well, actually, I should probably cover procedural. So procedural is probably something really simple that you guys already know, but you guys just never heard the name. It's just you take your program and you run it line by line. So you look at the first line and it might be like add 5 + 3. And so you do 5 + 3 and it could be saving it to a variable. So you have a variable or saving that value. So you do 5 + 3 and then your next one says 10 - 2. And then the final line says combine those two results together, and that's procedural. So it goes line by line. Structured is basically built off procedural in the sense that is so structured. You might have these if loops, or not if loops. You might have if statements or for loops, and you might have conditionals. So it might be like if I'm hungry, then you execute these lines, and then but if you're not hungry, then else, right? So if you might check a condition, and if the condition is not true, then you run this stuff. Or you might have like a for loop where it says, all right, run this through 10 times, or for every element, for every item in my grocery list, you do something. But so structured is basically procedural, but then you can have basically some more complex stuff happening. And the object-oriented finally is where you have classes and you have basically objects, right? So you have objects that are you can perform actions on these objects. These objects have a state within them, and so it might be something like a car, right? You could have a car could be, or you could. This is all like kind of conceptual, but an object-oriented paradigm can have like a car, and then the car has a couple of things you can do to it. You can make it drive forward. But you can also check on its state, so the state of the car. So you might like be how many tires does it have, or how much fuel does it have left. Those are all states. But then you have all these attributes, and then you can also do stuff with your object. And so that's object-oriented programming. And they come from so that's object-oriented programming. And so some common programming languages in this imperative programming paradigm, C, C++, Fortran, which is pretty old, and then for us, Python and Java, which are what we are going to use in this clip. So Python and Java are both actually Python's object oriented. Could be usually what you have is multi-paradigm languages, so it can be a combination of a lot of these. So Java and Python can so Java and Python, they both are considered imperative. And then you have declarative. So declarative, Haskell, SQL, Prolog, HTML, Excel. Oh, actually, Excel is not a programming language. That's kind of a joke. But for the first four, basically, you tell it something to do, and you don't care how it does it. As long as it gives you the output, you're good. And so for something like HTML, it's used to make websites. And basically, HTML, right? You tell it, all right, you're gonna put this text, and it's gonna have it's gonna be a heading, and then you put the text, and then your computer does it. You don't, and as long as you see it, you're basically good. And SQL is a server query language, and it's basically for databases, and you can hold the database, and an SQL a query SQL command can be something like finding. You can find SQL can be like you find, all right, so you got this database and you got these people under the database, and then all right, you find these people who match with this condition, who are like a developer you can like imagine a company with an SQL database of its employees, and the company and you have a query, you have a query question, or you ask the database, all right, I need to find these people who do this thing, and then who are developers or work in this department, and then SQL runs it for you. It gives you results. You didn't really you didn't tell it how to do it. You just said, give me this info, and it gave it back to you. So that's declarative. And imperative on the other side, you got to tell it explicitly. All right. And so we might go a bit over time again here, but we'll quickly set up Java and Python. Okay. So both Java and Python, we're going to be using Visual Studio Code. If you guys already have other development environments set up, you guys don't really have to worry about it. But Visual Studio Code, you can go over to this link, and then when installing, you can. Oh, I don't even know if we have enough time for this. All right, so you can just hit download for whatever operating system you have, and then when installing, there should be an option to add to path, and so you have to make sure to select that add to path. Here, let's see. How long will this take for me to download? All right. Dang, that's kind of fast. All right. Actually, I already have Visual Studio Code installed, so I don't know what's going to happen. Okay, but yeah, right here, add to path. Make sure that's installed. And then you can go through next, and you'll be good. But you can read through the rest as well. But make sure you add through path. I already have Visual Studio Code installed. It shouldn't be too hard to set this up. Once you might have to restart your computer once or twice, but that should be, after that, you should be good. And so once you have Visual Studio Code installed, I'm going to exit the setup. Here's your Visual Studio Code, and then you can open here. Let's see what this is. All right, you can click on it, open a new file, or actually when you first click on it, there'll be nothing, or it'll be like some kind of release notes or something.
Wait, Daniel, we can't see it because you're only sharing the Chrome.
Kind of a prank. All right. Oh, okay. Wait. So then you probably didn't see. Okay. So after you download it, here's your setup thing. Okay. Wait. I have to close VS Code first. All right. Oh, okay. Here it is. So you can accept, and then you can next. You can read through all these. But the important one is path. You got to add to path. And basically, what path is path is an environment variable. And what environment variables are basically these variables, this info stored on your computer, and it can have a bunch of there's a bunch of stuff, and it's just for your system. So some stuff your system might need to know for programs. And the path variable is basically when you want to run a command, you have to run, or when you want to run a executable file, a .exe, you got to go find that exe, and then you have to run it. But then path, what it does is it adds that exe to this path variable, so that this path environment variable, so that when you run it, you can actually you don't have to go to that folder location and run that exe. You can just run it wherever because it's added to your path variable. You guys can probably do some Googling on it too, but if you guys ever played Minecraft, I think you have to add your path variable. If you ever set up a Minecraft server, you'd have to probably add it to something to your path variable. But yeah, so path variable is just to make sure that your computer knows where to run VS Code, basically. All right, so after you go through this setup, you should have VS Code installed. And then when we open this, when you open it, you probably should have some welcome or something. And then after installing VS Code, so we go back over here, we gotta install CodeRunner, and CodeRunner basically helps us run Java and Python. And then for Java, we actually have to install also the Java extension pack. And so when you install the extensions, this is being recorded, by the way, so if you guys have to watch it back later. But after installing VS Code, you go to extensions right here on the left side. You can also press Control-Shift-X as it says. And then, so it's over here on the left side bar. And then you can search up CodeRunner. If you search up CodeRunner, and then it should exist. And then I have it installed already, but then you should be able to install it. So there should just be an install button. So it looks like that, install, but just for like CodeRunner. And then for Java extension pack, that's another thing you need to have to make running Java a lot easier. There should also be an install button. And so you have to go over to this extensions area. All right, so we install VS Code, make sure to add path, and then go extensions and install CodeRunner. And then for Java, we also install the Java extension pack. And then we got to install the Java development kit, known as JDK. Yeah, actually, let me pull this down. So JDK, we got to install a JDK. So if we go over to oracle.com/java, blah, 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 we install a JDK. And then what you guys, or for Windows, you have to scroll down. And then for Windows, you install either the bin.zip or the bin.exe. Bin.exe is usually, you can just click on it. You can you hit accept, and then you download it. And it actually might be a pretty big file, like like 100 megabytes, if it ever downloads. I have a feeling there's gonna be like, all right, let's see if it downloads. Come on, man. I have reviewed. Yep. Shoot. Okay. Well, hopefully on your computer it'll download. There should be a little download button. All right. Okay. Maybe it doesn't download, but hopefully on your computer it'll download. And then after downloading it, you just go to the setup. It should be similar to VS Code. And wait, does this really not download, man? Or maybe I don't know. I don't know what's happening. Maybe let's try this one. Oh, keep. Okay. I guess we're downloading. Okay. So, oh, we don't want to do that. Okay. So if you, for some reason, if the exe doesn't download, we can also download the zip, and then we can extract it. Wait, I don't know if this is actually gonna work. I've never done this before. It's a first. Just kidding. All right, let's see. Does it work? Oh, okay. So it only gives you, okay, this actually only gives you, well, you'd have to move this in actually then. Okay, just make sure to download the exe. If you download the zip, you might get pranked. And it doesn't really, you would have to kind of set it up by yourself. Does this really not download? How does this not download, man? All right, but hopefully it downloads. And then after you download it, you'd have to probably restart maybe once or twice as well. And then you'd have to edit your path. This is that thing, add to path. You'd actually have to do it manually. So how you would do it on a Windows computer, you would have to go hit home and then search up environment variables. So go home and you can search up environment, right? And edit system environment variables and bring you here, and you click environment variables. And then you're on this window now, and you'd have to go to your, I assume it's going to be downloaded on your system. So user variables is for your own, like your own system. But if you have something like Java, which is downloaded on your system, you'd have to go to the system variables, and you have to go to path. And then for me, I have the JDK 14.02. And so but for you, nothing would show up here. So you would have to create new, and then you have to go to C program files. So if you open your file explorer, C, and then program files, and it should be installed here, by the way. Java, and then your JDK, and then bin. And you'd want to add this bin folder so that all the java.exe file in here could run. And so after you've added that bin, you should be good. You save it, and then you'll be good for Java. Python's a lot easier. You just download. You go to python download.org to download this. It also has a, let's see. It also has add to path. Make sure to check add to path, and then you can install it with just your custom installation. And that should be it for Python. Okay. So that's basically it for setting up your overall process, setting up the overall process. If you guys have any questions or need help setting that up after, you can definitely message us on the Discord. But yeah, that's basically it. I think Senkai can go on to reusing code now. All right.
Okay, so wait. So let's talk a bit about reusing code. So, okay. Oh, by the way, if you have to leave, you can just leave. We'll still give you the recording afterwards. Yeah, just remember to check back. Okay, so before we go into how code reuse differentiates like programming languages, we should really talk about what it is first. So if you haven't heard of code reuse, it's basically like the act of using pre-existing code to write new code. So to know when you want to reuse code, just ask, has it been implemented already? Because if it's already implemented, then you should not duplicate the code or reinvent the wheel. So the reason why you want to reuse code is that it saves you time, since you don't have to implement it again, or yeah. And if by reusing code you have deduplicated like parts of your project, you have just successfully saved space both in the source code and in the final executable by converting duplicate into functions, classes. So it can also result in cleaner code, as you probably have abstracted was 10 lines of code into a function called object instantiation or macro, etc. There are two ways to reuse code. One is to check if you have already written code that relates to the feature at hand. And the second way is to reuse. The second way to reuse code is to check if others have implemented similar things that you're thinking about, so you can borrow from them, assuming it's legal. So check the license first. Oops. So to expand on the how of reusing code and how it differs between programming languages, there are three aspects I want to cover. If you find that what you want to do has already been implemented, try to make sure that it is a function or a class that you can reuse cleanly and efficiently instead of just copying and pasting code over and over again. If you're thinking of implementing a utility function or a class, try to check with the standard library of the programming language you're using and see if it already provides what you're looking for. A standard library is a set of functions, classes, utilities, etc. that the programming language that you use already provides by default. As you can see, Java, Python, and C++ already provide the implementation of a generic stack class. It's like a basic data structure if you haven't heard of it. All you have to do is to in Java import the right class, use the right notation for a list in Python, or include the stack header in C++. So major programming languages like Java and Python also have like massive number of libraries and packages to choose from. You can usually download them from the internet or install using a package manager like pip for Python, if your language provides one, that is. So to the right of the slide, you can see the installation process of the Django framework, or however you pronounce it, for web development. In Linux, with 3 commands, you can start developing your first Python web server without having to parse HTTP requests and send responses manually. One of the benefits of a scripting language like Python or JavaScript, by the way, scripting language is basically like synonyms with interpreted languages. So the benefits of them is that the process of installing packages is like very streamlined and convenient. These packages also gives you modules that you can use through the like using the import statement in your code. Python offers over 200,000 packages to choose from on the Python package index, I think. You can even find usable command line applications in some of these packages. Package managers like pip are not limited to scripting languages, though. For instance, with Go, it's another programming language, of course. With Go, you can download necessary packages or dependencies using the go get command. So programming languages differ in the way that the code can be reused, and there can be differences in all 3 aspects presented here. With different programming paradigms and syntaxes, you might be able to achieve different levels of reusing code. Things like macros and object-oriented programming, like classes and stuff, can change how your code looks significantly. If you're using stuff like SQL, you can simply borrow the tables, procedures, and functions by dumping the database as an SQL script and running it inside a new database. Languages often have very different standard libraries as well. The C standard library, for example, only implement a small set of basic functions, constants, and structures. Python and Java, on the other hand, contain many more built-in utilities and classes. A robust standard library means better usability and often higher popularity. Okay. The way in which others' code are used makes a great difference too. In C and C++, to use an external library in C and C++, you either pray that the package repository already has the library that you're looking for, if you're using Linux, or you can download them from the internet, regardless of your operating system, and set up the include path and manually tell the compiler which libraries you're using. And yeah, that's a mess. In Java and Python, it can be much easier. You have already seen that on the right in Python, you can just install a package from the package index, like using a simple command like pip install something and import it right away in your code. And for Java, it's still much easier than C++ or C. If you're using Gradle, for example, you can just add a line of dependency in the project's Gradle script, and it'll automatically get it for you. import it somewhere else in the code and you're set. And that'll be all for this section. And let's go to. So in general, programming languages differ in whether they're high level or low level, whether they're compiled or interpreted, the programming paradigms they support, and how code can be reused, and in particular, the use of external libraries or packages. The two main examples we used, Java and Python, are both solid choices for first or second programming languages, as they are both widely used and multi-purpose. You might like Java for its statically typed object-oriented nature, or you might like Python for its utter simplicity. You might also dislike Java for its verbosity, or dislike Python for its pedantic indentation requirements. Unless you have a personal preference, you can't really go wrong with either language in 2020. Next lesson, we'll move away from the theoretical discussions and get into the details of how to actually use these two languages.
Okay, so we're basically done now. The last thing we have is that, in case you guys don't know yet, Cybersecurity Club, which is also CSC, so they're going to be having a computer architecture basics lesson. It's going to be on Friday during lunch. It's going to be also run by Zenkai and Daniel. And you guys should stop by and check them out and pay some attention to their lesson if you can, because computer architecture is pretty useful, especially when it's related to, it's the more hardware parts of the computer, which isn't directly related to what we're learning at the moment, but it's pretty useful in computer science. So you should go and stop by if you can. And that's basically it. So if you have any questions, you can message us, you can put in the chat right now. Otherwise, we're going to end the meeting pretty soon.